Thank you all for coming. It's great to see so much interest. I'm Judy Lara Jacobs, the Executive Director of Green Newton. And at Green Newton, we work with residents, government officials, and businesses to reduce greenhouse gas emissions and build a more sustainable community. And we're excited to see so much local interest in network geothermal. As Peter Bear will discuss in a few minutes, it's a promising approach to heating and cooling buildings more efficiently and with lower emissions. This effort reflects Green and Newton's commitment to advancing real community-based climate solutions. With support from a heat grant last year, we began exploring the possibility of a pilot project here in Newton. One of the main areas we're looking at is the neighborhood around Countryside School. And as you may know, the new school building will include a geothermal system designed to be able to connect to a neighborhood network. And to find out whether a neighborhood network is technically and financially possible, we need your help. We're collecting heating and cooling data from nearby homes through simple, no obligation home visits by trained volunteers. And if you live near Countryside School, please consider signing up. Your participation is essential in helping us explore whether innovative renewable energy solution can work right here in Newton. And I'll put the link, I think Peter put the link in, and I'll put it in a little later for those of you who are coming in later, for you to sign up and so that we can contact you to set up a meeting. And now I am thrilled to introduce Peter Bearer, who's going to give you an overview of geothermal and network geothermal and the pilot project. And if you have questions, you can put them in the chat, or at the end you can raise your hand, either virtually or for literally, and we can answer questions. Peter is the founder and former president of Demand Management Institute, a New England firm that helped large buildings use energy more efficiently. Since selling the company, he's been a key leader in Newton's climate work, serving on the city's design review committee and helping launch solar in our public schools. Peter, it's all you.
All right. Thank you, Judy. I'm going to share my screen. And there we go. So this is all about a new idea, exploring an idea using network geothermal for the neighborhood around Countryside School. And this is an exploration. Nothing is decided yet. Green Newton is taking the lead into seeing if this can be done, what's going to be needed, and developing, interest and see if we can make it happen. Okay, so somebody else is admitting people in. I'm not going to worry about that.
That's me.
Okay, great.
Oh, I'm doing it too.
So the main thing, the first thing about network geothermal is it doesn't use fossil fuels. It uses electricity, which can be made 100% renewable. So, the building sector accounts for about 30% of CO2 emissions in the state. And I think that's also true for Newton. But you can see it's a building sector operations is a huge contributor to global warming. And there are two ways to do it. If you use energy efficient electric heat pumps instead of gas or oil furnaces or propane, and power them with renewable electricity, you have really eliminated fossil emissions from heating and cooling. I'm going to move this pretty quickly, but if anybody has any important questions, please speak up and I'll stop for a second. But I think we all have varying knowledge of this stuff, and I want to cover it all and just touch on everything. So what's happening is the heat pumps are selling gas furnaces, and they continue to. This is older data. I don't have any newer data, but you can see the green line is heat pump sales in the US, and the black line is gas furnace sales, and this is increasing and increasing. So this is the right trend, and it's proving to be workable, and it works. So what kind of heat pump? So heat pumps are actually, everybody has a heat pump already on your refrigerator. The heat pump moves heat out of the refrigerator and drops it into the house. Um, and or an air conditioner removes heat from the house and dumps it outside. So these are already heat pumps that we're familiar with. We just don't call them that. The air source heat pump, is also called a mini split, can heat or cool the inside of the house. In the winter, it takes the heat that's available in the atmosphere outside the house and turns it into heat that can be used inside the house. And then in the summer, it reverses the process and takes the heat that's inside the house and sends it outside. It's the same operation, just as if you had turned a air conditioner inside out. The ground source heat pump uses, instead of the air, uses the heat that's in shallow ground, which is like 55 degrees year round. And in the summer, you can use it as a source to reject heat, and in the winter, a source for heating. And then you've got your network geothermal, which is what this is about, which combines many buildings in the same loop. And I'll get a little later into the advantages of that. So these are the kinds of heat pumps there are. So now, what kind of geothermal? Starting at the left, if you have this is common in Iceland, if you drill way down into the heat of the earth, you've got a constant source of heat. It can be used to make steam, and you can or take that heat and use it to serve buildings directly. There's no heat pumps involved. The heat just comes from the center of the earth, many thousands of feet deep. Or you can also use that same heat to drive a steam turbine to make electricity. And this is successfully done. It's a very deep well and a central plant kind of approach. Those are both geothermal. Um, more accessible in Newton in Massachusetts is a single home geothermal. These are much shallower wells, less than 1,000 feet deep, and they go to the 55-degree earth and use it as a source for heating and cooling for a single home. And over on the right, network geothermal is what we're talking about here, is you put many of these buildings and a variety of buildings on a single loop. The advantage of this is that take an office building in the winter, which often doesn't need heat. There's so much heat inside just generated from the lights and the people and the equipment. And you could share that heat with a home. And that way, it's a source of free heat. And each of the buildings in a network geothermal has its own heat pump, and the water circulates at 55 degrees. All right, I'm going to keep moving. So, and this is what a network geothermal schematic looks like. You've got a ground source heat pump in each building. There's infrastructure in the street with the boreholes going down as much as 1,000 feet. And it's a closed loop system. It's filled with water, and the water just circulates around and around, dropping off heat and picking up heat in each, for each part of each building, and each also using the ground. And I'm going to show this short video about how this all works. If you, somebody speak up if you don't hear the sound.
Right beneath our feet, the Earth is soaking up energy from the sun, and it's been doing this for a long time. Near the surface, the ground warms and cools with the seasons, but lower down, it stays at a constant temperature. In Massachusetts, that's 55 degrees Fahrenheit year round. This stored temperature is a source of renewable energy. It can be accessed to heat or cool a single building without using fossil fuels. But did you know we can also connect entire communities to that renewable source in the ground? How does it work? It starts with underground pipes in the streets, sort of like gas pipes, but filled only with water. The water absorbs the ground temperature of the earth and delivers it to buildings. Pipes connect buildings with different heating needs, so energy is never wasted. Instead, it's exchanged between buildings or stored in the ground until it's needed. Inside, a heat pump moves heat in or out according to the temperature you want. This system of pipes can connect like Lego blocks, gradually moving us all from gas to geo, giving us cleaner air, efficient heating and cooling, and a healthier planet. The idea for this networked geothermal system, run at a utility scale, originated at HEAT, a climate solutions nonprofit. When Zainab Magavi of HEAT found out how expensive it would be to install geothermal for her home, she asked, instead, could a utility provide geothermal energy for me and my neighbors for the same monthly energy bill as gas? Zainab worked with HEAT founder Audrey Schulman and the HEAT team to bring gas utilities, workers, climate advocates, legislators, regulators, and neighbors together to make this system a reality. Demonstration projects are now moving forward in Massachusetts and across the country. This technology can deliver affordable and reliable energy to our buildings. And unlike gas, it's locally sourced, safe, renewable, and can help get us to zero emissions. It's time to modernize our energy infrastructure to meet the needs of our future. The answer is right beneath our feet. Learn more at heet.org. Right beneath our feet, the Earth is soaking up energy from the sun, and it's been
Okay, I didn't want to show it twice, but I hope that was helpful. So there are many areas around the country that are looking at possible network geothermal. This is a map of some of that. It's an older map, 2023. There's been more interest since then. How efficient is network geothermal? Well, here it compares a gas efficient, a high efficiency gas furnace has a COP, which is coefficient of performance, where you put 1 unit of energy in, you get less than one out. And the newest gas furnaces are at 95% efficient. So they're a COP of 0.95. Air source heat pumps have a COP of about 2 to 4, depending on the outside air temperature. When it's especially cold, they're less efficient. As it gets warmer, they get more and more efficient for heating. And the geothermal networks have an average coefficient of performance of nearly 6. That's because they can count on using the ground temperature of 55. I'm an engineer, so this all makes sense to me. I'll welcome any questions later if you have any. So as the video showed, the benefit of this is you can share the heat. So this shows a office building that needs cooling, and it needs cooling, and it throws away its heat back into the loop. And I think, yes. So here you got the cooling going into the building and the heat coming out of it. And then that heat can serve all these other buildings that are on the same loop. It's a really clever idea and very efficient. It works best when you have a variety of different types of buildings. So I'm going to go through the benefits. First is safety. there's no gas to explode, burn, you know, and we're reminded of what happened in 2018 in Merrimack Valley. You can use it for heating and cooling. Your bills get lower with net geo because you've got such an efficient source of the 55-degree air, 55-degree ground as the source for heating and cooling. Of course, you're cutting the emissions of outdoor carbon dioxide and also indoor pollutants. Gas has been found to, release pollutants even when it's totally sealed within the house. You're still releasing carbon dioxide and other oxides of nitrogen and other things into your home air. And then if it's at all leaky, you've got methane also going into the air. It can be used to serve a whole lot of people because you're doing a whole neighborhood. You're not relying on the individual homeowner being able to afford drilling the wells. It's the cost is shared among everybody. And it provides good jobs for workers. What's very attractive about this is that the workers in the gas industry have been laying pipes and connecting homes, their careers. Those same skills can be used to do network geothermal as water pipes. And the same applies to a gas utility. They could, instead of going out of business because gas is no longer being used, they could go into the heat business instead. So where is this being used? This development in Austin, Texas is operating. There's, I think the one in Toronto is partially built and operating now. And it's much easier to install when you're building a whole new development because you know what's in each house and you're building the streets at the same time. And that's sort of the first way to, the easiest way to do this. It's also being, Colorado Mesa University has had on campus a shared geothermal network for 10 years. Mount Holyoke is putting one in or has put one in by now. And in Framingham, Eversource has installed a pilot project in downtown Framingham. Here's the workers putting in the water pipes. And this is a map of the schematic of the shared system in Framingham. You can see it includes the Framingham's Public Schools Welcome Center. There's a housing authority series of buildings. The Framingham Fire Department is on the loop. There's a gas station that's on it. And also, I think 24 homes, 20 single-family households and two-family households. And this is where, this is an example of what we think we might be able to do in Newton. And this, now you run into the complexity of each house is different and all the homeowners need to agree to proceed. But it's been installed and it's working now and people are running on geothermal. And they've also made the decision to expand. So the expansion plans are now on the drawing board and it's going to expand. The nice thing about, you can link these together. So you could put a new system up here on the right and link it into the same water loop. And the more diverse the loads, the easier it is. So the Countryside School is under construction. The construction fence is around it, and it's scheduled for completion in 2027. The school is all electric. There's no gas provided to the school. Everything is electric. Heating and cooling is electric. And the heating and cooling is done with geothermal HVAC. That's heating, ventilating, air conditioning. So that there are wells about to be drilled in the fields around the school. under parking lots in the fields, and all you taking advantage of that 55-degree earth temperature, which will be used in heat pumps inside the school to provide heating and cooling. No emissions and very efficient. And what Green Newton is now doing is exploring what if we could network that geothermal system that's being built to the homes in the neighborhood. So this is a map of the neighborhood around Countryside. And I drew this, the center is this Countryside, place where the school is, when the new school is being built. And then this dotted line is about 1,000-foot circle around it. And that's a first guess as the easiest place to network to the school system. And we would love to have streets in this neighborhood decide to join the, network into the school system. You will need extra boreholes. The school doesn't have enough to serve the neighborhood. But by combining the school loads, which are different from the home loads, the whole system gets more efficient. There's also a dotted line here showing the possibility of getting over to Needham Street, which has restaurants and medical facilities and other things. There would be even a more diverse load, and that's also a possibility. So this is what we're doing in Newton. We're exploring the possibility. And you're a part of this first step, which is gauging community interest. Are people interested in doing this for the various reasons that I showed in the earlier slides? And wherever there's interest, we are holding home surveys. It's no cost, no obligation, and a trained volunteer will go into your home and pick up, basic information. How large is the home? How are you heating and cooling now? What's your source of fuel? How efficient are the windows and the wall insulation? So forth. When we've collected enough of this, and we have a target of getting a good 50 homes in the neighborhood, we can present something to an operator. We're talking to an operator who's very interested. He's taken a look at our survey information and our process, and he's very interested in working on this, but he has to have enough customers to decide to make the investment. With an interested operator, they can explore the financial viability, the cost of drilling the wells, laying the pipes, connecting up in each home, and putting together a good deal for each homeowner. If the deal isn't good enough, nobody will sign up. So we're hoping that with enough, enough interest from the homeowners and a good planned operator, that the project would be financially viable, such that the homeowners can sign on to a deal that looks good to them. And then there's permitting and legal issues that have to be resolved. For example, if the operator is not the gas company, they have to get the permission to lay new pipes in the streets. And we haven't found any obstacles, but that's untested. And so this will also be, solved and addressed by the operator. The best operator would be the gas company. And if they get attracted to this kind of situation and see that they have a future in selling heat rather than selling gas, that'll make this whole thing move much quicker. But right now we're relying on an operator who's in the business of doing this. So here's where you come in. We are asking people who are interested to have your home surveyed. And in the chat, Judy will be putting in this link, or you can scan this code And that gives you the place to sign up for a free, no obligation, done by a neighboring volunteer to visit your house and collect your information so that we can present to the operator what you know what the business opportunity looks like. So last one letter of encouragement, complete the survey and I'll answer any questions. And I think I'm going to stop sharing my screen.
Great. Thank you, Peter. Do you want me to read the questions for you?
Sure. Yeah, that's a good way to do it.
Okay. So first, Lynn is asking, is there any comparison for a house that uses oil?
Yep, this is the thing. For a oil, it has been more expensive than gas. So the savings for someone who's heating with oil now will actually save even more than heating with gas. And a home that's heated with oil is no more difficult to convert than a home with gas. And it kind of depends on how the oil is, if you have steam heat or hot water heat or air heat, it's all different costs, but the complexity is really the same.
And a follow-up question, how do you control the temperature in each room of the house?
With heat pumps, well, it depends how the heat pump is arranged. If you, the simplest is if you have a single zone house right now with, say, water heat, there's no control in each room. But if that's zoned, you can also zone a heat pump. You can have individual split systems, or there, it's, the opportunity is there to control heat. It's more expensive to do that, but it can be done.
And Lynn, did you mean what temperature can you get the house to be? Like, can you get it to be really warm or very cool, or how much can you control it? If that wasn't your question, you can write it again.
That was my question.
Okay, great.
How warm can you get it? Because I've heard that people who have heat pumps now, it's not warm enough in the winter.
Great, thank you.
Well, let me answer that. The air source heat pumps, the newest ones, are designed for cold climates, and they can heat the house, under all conditions. The older ones, some have run into that problem. But the benefit of the network geothermal is you don't care how cold it is outside because you're running on 55-degree source heat from the earth, and there's really no problem.
Then Ben is asking, what does the survey need to be in home? Can we instead provide this via email, etc.?
We talked about doing that, and it might be possible. I think we're more likely to get consistent information if our volunteer gets to the house. That's the reason why we're doing this. I think if there's a big demand for it, we could probably accommodate that. But there's a certain amount of training for each volunteer to learn how to do this. And I don't think we want to train every homeowner how to fill out the survey.
Yeah, maybe a Zoom call or something.
Yes.
But if you're interested, you can sign up and then we can chat and try and accommodate you. Tom is asking, in current installations, Utah and Colorado, etc., were those new neighborhoods? Good question.
I think the Holyoke College was not a new installation, but it was easier because they own all the land. They didn't have to get permission to dig up streets. I don't know about the one in Colorado, but I expect that it was also had the benefits of being like a campus easier.
Yeah.
The one in Framingham, I think, is the first one done as a retrofit in existing homes.
Nancy is asking, are you only collecting data in the countryside neighborhood, or are you also collecting data in other parts of Newton?
Judy, you can answer that one.
Sure. So we're prioritizing the area around countryside, but we would love, if you're interested in network geothermal, we would love for you to sign up. because we're kind of just poking around. Countryside seems like a good location now, but we might come up with a different location that has the diverse energy source and kind of might be a good pilot, and you might be in that area. So we would love to know who's interested. So at the moment, we're prioritizing Countryside, but please sign up if you're not in Countryside. Cindy, I just saw that Franklin School will also have a geothermal system. Will you be serving people in the Franklin School neighborhoods as well?
Yes, Franklin is going to have its own geothermal system, and we would love to do the same thing at Franklin. We picked Countryside because that's the first one. And yeah, love to do it.
Right, exactly. Nancy, do you have any cost estimates? Yes, yeah, and variable.
This is the big question, and the answer is really no. The Framingham project is not even a good basis for a cost estimate, and it's being talked about as a prototype. And when you build a prototype, it's very expensive because it's the first one. I've heard that the estimates for the expansion is coming in about half the cost of the first installation. But we really don't have good, there's not enough experience to say what the cost is reliably. I mean, you can estimate the cost of converting inside each home, but the cost of permitting, the business expenses of running a new business this way, all of that, we don't have the experience to know yet.
Sorry. Nancy is asking, in my neighborhood, the houses are rather far apart. Would this be a problem?
It shouldn't be. That's another question that we need to learn and find out about. If they're too far apart, if you're a quarter mile away, then the cost of the water pipes is going to turn out to be very costly. But in general, in Newton, the houses are, maybe 100 feet or 150 feet away. I don't think it's a problem, but we have to learn.
Right. And Micah, you have your hand up. You're on mute still.
I would like to question so just I don't know if you
I'm having trouble hearing him. Can you understand him?
No, I can't.
Oh, we're having trouble. Sorry.
Let me try this. How about that?
So much better.
Is that better? Okay.
Yes.
Great.
Okay, thank you. I don't know if we have any representatives from the city here. What is the city's stance on sharing Countryside's geothermal wells?
In a nutshell, well, we do have Julia Maliki. Councilor Maliki is on the call. Thank you for joining us. But she's not going to represent the city on this one, I don't think. We've had good discussions with the city, with the Facility Buildings Department, with the mayor's sustainability team, and they are very interested in what we're doing, and they like it, but they don't want to endorse it. It's too early, and they've said up to date that they don't want to own the system. Now, I think that I hope that will be reconsidered later. But at the moment, they said you have to do this with work it out with a private operator. So and then they've also designed the school to enable a connection to the neighborhood if we get to that point.
So both Countryside and Franklin are designed so that they could be networked.
Okay. So what would be the advantage of joining with Countryside's wells as opposed to just doing our own network among homeowners?
Great question. One is that the profile of heating and cooling in the school is different from the neighborhood. So, for example, you can use the heat that the school throws off in mid-season to heat the homes, and the other is that the loads come at different times. So when the school, needs heat, maybe you don't need it in the homes, or in the summer, you don't need the school's not using cooling that much. So you can serve a mixture of loads with fewer boreholes. So there's a big cost savings when you have a mixture of heating and cooling and different loads. It's advantage for both the school and the neighborhood.
Yeah. I'm just gonna keep going until you stop me, Judy. So who would decide the cost sharing between the city and homeowners?
It's the city will have no cost. That's what they're saying. The
Okay.
city is financing the full cost of drilling the boreholes to feed the school.
Okay.
And then the homeowners and the operator will figure out everything else out.
Okay. Okay.
Why don't we give a couple other people, but we can totally come back to you for answer
Thank
as
you.
many questions as you want. So Tom is asking, oops, that disappeared. How large a borehole is required for each house? Is this a multi-year project to retrofit a neighborhood?
It's let's see. I can't tell you how the
So
borehole size depends on the nature of the earth beneath the school or in the neighborhood. So, and that's, I haven't done the analysis of a typical house. Generally, if you have your own house, it needs a full borehole. But I think a series of houses, if you had 5 houses, maybe you could serve them with 3 boreholes. But it all depends, partially depends on how deep they're drilled, and that's a cost issue. So, and there was a second half of the question that I haven't answered.
is this a multi-year project to retrofit a
Oh,
neighborhood?
yes. So, I would say it's at least a year if you were very well organized. And I think an operator who's making the investments would do it this way. You could probably convert the neighborhood in a year. The Framingham project took a couple of years.
Nancy was also wondering about the size, diameter, not depth. But I think you said you can't answer that.
Well, it's something like it's just like a 6 or an 8 inch hole, big enough to put 2 pipes, supply and return.
We currently heat our house with gas. Does joining geothermal mean that we lose the gas heating?
Yes, you would.
Yes. Micah, we can go back to you. Do you have other questions?
Oh, great. Thank you. Yes. How would costs be distributed among users? I certainly some will be using more heating and cooling than others. So who would decide? Would we have meters or how would that be distributed?
Yeah, it's easy to install what's called a BTU meter, and it measures the flow of water in and out of your house and the temperatures in and out. And every house would pay. I think there'd be a connection cost, a monthly connection cost, and a BTU cost.
Okay.
Well, Pat, here, Julia Maliki says, do you get as much heating or cooling if you're on the outer perimeter as you do if you're closer to the school?
The answer to that is yes, because the water is being circulated by pumps. So wherever it is, the water gets moved around. There's no problem being at the outer edge.
Lynn asks, is the hole drilled in the street or on the house property?
The original concept is it would be drilled in the street, and that the city would give the operator authority to drill a hole in the street and then pave over it. There is an alternative that homeowners could choose to have the borehole drilled on their own property, and that I think we'll leave that to the operator if they can, do deals with individual homeowners. They get a break if you allow the borehole on your property. That would be how it could go either way.
Micah, do you have more questions?
I have many more. Yes. Once built, who would administrate the network?
The operator.
The
So
operator. Okay.
yeah, if it's a gas company, or the heat company, or our independent operators are the people we're talking to now.
Okay. Okay.
Ben has a question. Eversource seems to have a geothermal pilot program in Framingham, and that project was supported by funds from state grants. Are those options available to us, or is it too early to know? Is Eversource a potential operator?
I'll answer the first one. Eversource, yes, is a potential operator. Although Eversource only provides electricity in Newton, the gas utility in Newton is National Grid, and that would be a more likely possibility. But if Eversource figures out that they can, expand that way, they could for sure do it here because they know how to use streets for distribution of utilities. That was only the beginning part of the.
Seems
So the Framingham pilot, yes, was supported by state grants. And the legislature has decreed that gas companies that are installing geothermal can use their state funds in the gas rates to support geothermal. So, the gas companies are not leaping at this at the moment, but the Department of Public Utilities in their latest ruling emphasized that they want to see this explored.
Still you right now, Micah.
Okay, yeah. Well, how would maintenance costs for a geothermal network compare to, say, a gas line system?
In the house, I think it would be less expensive because, well, similar to an air conditioning system, but you don't have gas to, clean surfaces. You don't have to check the safety. You don't have to check for gas leaks. But there is also the maintenance costs of the pumps and the pipes to maintain those in the streets. So that's an operator expense that would be built
Okay.
into the rates.
Okay. If we installed geothermal systems in our homes, would those be mass save and tax rebate eligible?
Tax rebate, I sure hope so. And currently, yes. And part of the reason why the schools can do it in Newton is because there are federal incentives.
Our Mela in the chat.
I was actually just typing that up. There is a Mass Save Newt / Newton page right now where you could reach out to, and you'll be in contact with me starting from June. I'm the energy advocate for Newton, so we will look that up together and go through the journey and see if the qualifications and all the exact details. I don't have an answer yet, but I will have one soon.
We're excited for
Okay.
our Mela to start in June. Edison has a question. How does this compare to electrifying homes with SHP instead? Is there a minimum number of homes to get to break even for the total system costs?
Yeah, I'll start with the last question. Yes, I'm sure there's a minimum number. My personal guess is 50 homes, but I haven't penciled out the costs and everything. And we're going to learn from our interested operators what the number of homes is. But you need a significant number of homes to make it worthwhile. And the first question, I'm sorry, I can only hold one thing.
How does
in
it
my mind.
compare with electrifying homes with the ASHP instead?
Okay, that's an air source heat pump.
Oh, okay.
And it's less expensive to install an air source heat pump than it is to install a geothermal heat pump, mostly because the geothermal requires drilling boreholes. So the disadvantage of the air source is that the operating costs are significantly higher than geothermal. And the energy use.
Great. Other questions?
Yeah, I was wondering, within a home, can an existing HVAC system be retrofitted to integrate with a geothermal heat pump? So if I have an air handler, existing air handler, can I switch that from an air source heat pump to a geothermal heat pump?
Absolutely, yes. If you have
Okay.
that kind of system.
Okay.
The systems that don't transfer that easily are water or steam systems.
Okay. And would it be possible to enter the network later? It sounds like once once the initial sign up is set, it would require a network expansion to add or enter into the network.
That's right. I think that the operator would be very eager to add homes to the network. And if you have a new segment of a street, you can extend the pipes that much further. And it doesn't require the big upfront cost of developing the whole thing. So the cost of adding one more house or one more street would be less than the financing cost of the original installation.
Okay.
Tom asks, how large a building is needed to support a 50-home neighborhood? Assume houses are 20,000 or 2,000 square feet.
I think those are all reasonable numbers. 2,000 square feet, 50 of them. These are all guesses right now because we don't have the experience. But I think those are all reasonable. Does that answer the question? Maybe I misunderstood the question.
I don't know, Tom, does that answer the question? You can write again if that doesn't. Lynn asks, how long does it take to break even to pay for the homeowner's cost of this equipment?
I hope that the payback of the cost to the homeowner will be very quick because that's a deal that homeowners will sign. But it's really up to the operator to put together an arrangement that works for the homeowners as well as for the operator. I don't know how long the payback, the homeowner cost could be. I think in the Framingham pilot, because of the way it was financed by the utility, homeowner cost was very low. And we don't know what Countryside will look like until we get a reasonable package that an operator can work with.
Right. And we wouldn't get a package unless we have enough people who have signed up for a home visit. Just getting out of no obligation. Did I mention that? Tom is asking, how large is Countryside?
Oh, several 100,000 square feet, but I don't know the exact number.
Great. Micah, did you have more questions?
I'm done. Thank you.
You're dried out. That's great.
Hi.
We did it.
Yeah.
So it looks like we have no more questions in the chat as well. But certainly if something occurs to you later, feel free to email me. I think I emailed everyone, except for the last couple of people that signed up, but it's judy@greennewton.org. And one last time, we'll put that link in for you to sign up for a home visit, which would be no obligation. And we're just collecting some heating and cooling information. And thank you so much for spending the evening to learn more about network geothermal. And we hope to be in touch. So thank you.
Thank you very much.